Right, everybody. Excuse me, sorry. We will actually continue our with our project number 3, which was a basically AI stack, and so we are on slide 8. The stack was basically it's a called power stack. I just called it power stack. Ollama, FastAPI, Chroma. Everything runs on Docker, and we'll have Grafana and Prometheus for the observability. So the whole idea, we this is the part 4 of the series, and we're just moving a little slower than we expected, but um, what you guys can see now is basically monitoring with Grafana. Why monitoring matters? Basically, in AI systems are general, like the systems engineering. We've been monitoring systems. We've been setting up alerts. We've been setting up metrics. And in AI, it's even more important now because we want to build responsible, more secure environments, right? We don't want to just throw out there some kind of a whatever agent we build and just to leave it out there. So what we want to do is we want to make sure that we build responsible AI agents, and those AI agents basically do whatever they're supposed to do. And if they're acting weird or if they start failing, then we need to make sure that they are inspected, they are fixed, and etc. Uh, so Prometheus collects metrics. So in this setup, Prometheus collects metrics from FastAPI and Ollama. Um, and then Grafana shows dashboards with API latency, model response time, error rates. This helps detect bottlenecks, failures, and improve reliability. So the whole idea is that we want to make sure that every request we do, everything we basically do, it's monitored and it's tracked. And these are this is one of the fundamentals of observability, right? So we want to make sure every request. One thing I want to show you guys, a really quick demo as part of this, is we have an endpoint called ask a financial advisor and generate. So I'm just going to make a small demo and to show you guys, just to just so that you can get just an understanding of what it looks like when I send the request. So this is the first request here, the curl request to the financial advisor. So I'm pasting my curl request here. I'm sending the request to ask financial advisor. So this agent is part of the project 3 agent. It runs the Ollama Chroma as a vector database. So it's small rag setup with the Ollama and a little bit of observability. So this project is great for like observability and then also the AI agent, right? So like you can just get an idea of like you can just do your own like a test with this kind of a setup. So which company first issued the stock? I'm just gonna run that, and then when I run that, so my Ollama is basically getting this request served, and so what we're gonna do is that we're gonna see right now in green that how fast this request is gonna come right now. We're gonna see it in a bit. So it's all right. I'm gonna send another request just to make it a couple of requests here. It's the same request. So what's happening here right now is just it's grabbing the information, and Ollama is serving that information. And right there, our request is coming up. So we're gonna see in a bit how it's gonna change again. So we're gonna go to next slide. Conclusion, next steps. What you've learned in project number 3 is basically what you've learned, how to deploy an AI agent with multiple components, why vector databases are critical for next context-aware AI, how to secure and monitor AI in production. Apply this to real use cases, healthcare, finance, and other sectors. Scale the system with Kubernetes. So like I said before, Docker Compose, I've been using Docker Compose, but that you want to make sure that if you put this in production, you want to stick to K8s. This is more of a lab demo stuff. If you want to do quick lab setup, then Docker Compose is great. So you can see my request here, ask financial advisor. It came in right here. And so that was the really quick demo. And now the quick demo we can do is actually this one here. So I'm gonna do another request, not financial advisor. So there is another endpoint that I want to generate right here. So that was actually the ask financial advisor endpoint was actually a RAG. So like if you guys remember, I mentioned it was using the vector database and then combining the answer from the LLM, large language model, and then with the vector database, what it has in store, and trying to combine those two answers together. So here now, this generate part endpoint is purely LLM itself. So this is not, this is not pulling out of the vector database. But the previous question right here, which company first issued stock? Dutch East India Company. If I come here, you can see that that Dutch East India Company right here it has it here, like that information is in here. So why did I put this in here? The thing is, like I mentioned before, with the vector databases, we use vector databases to make sure that our models do not hallucinate, right? So the hallucinations are very common, and sometimes LLM, they make their own assumptions, they make their own, the whatever information they collect, they just generate it together and just spit it out there. And that's the problem. We don't want the LLMs to hallucinate. And there we go, our request for the generate. So API request latency metric is right here. This is Grafana, and also just to show you, this is Prometheus right here. You can see it. Now what we're gonna do is we're gonna go back to the slides and try to wrap this course. Why RAG? So RAG is retrieval augmented generation. It's built around two ideas, right? Retrieve the relevant information from a knowledge base like a vector database, generate a response using an AI model like Mistral, Ollama. So in this case, you guys saw that the financial advisor, what we did is we combined, our advisor basically combined two answers together and then gave the, the final answer. So that's the, that's the feature of the RAG. Retrieval, R for retrieval. We're using Chroma as a vector database in this scenario. So the Chroma is our vector DB. Text is embedded into vectors, stored and queried semantically. When you make a search, when you make a, the request to a search or RAG API call, it retrieves relevant documents from Chroma based on meaning, not keywords. I haven't done that, but you can definitely go and do curl to the, vector database Chroma itself. This step gives your AI memory a memory or context awareness. Yeah, so the whole idea is basically the portion of the basically data that I gave is right here, right? And I put this data inside the Chroma, and then I'm using the LLM to kind of retrieve that information instead of LLM trying to hallucinate and trying to make up stuff. Retrieved data from Chroma is passed into the LLM prompt. The AI Mistral Ollama DeepSeek now generates an answer with a context. Instead of random answer, the model uses retrieved financial data for accuracy. So this is the augmentation part. And then the last part is generation. The Ollama model actually generates the text output. This output is informed by retrieved vectors from Chroma, and then that's what makes it augmented generation. So the last part, we're combining retrieval and generation dynamically. That's the heart of the RAG. So the whole idea is that we provide the information. We don't want our LLM try to hallucinate and make random answers. We wanted to make sure that it uses the answer that it has from the knowledge base, which is in this case the Chroma DB. So you guys saw a couple of the tests that I've ran, and so a couple of these curl requests I've done. If you have any questions, please post the questions. Go ahead and read this, download this document for yourself. Try to do this with on your own. So the stack was Ollama, FastAPI, Chroma, everything Docker composed with a Grafana Prometheus as observability. Thank you very much. I really appreciate it.